So now that we've seen enough of graphing, let's talk about how to draw a quadratic inequality when we have y bigger than a quadratic or y less than a quadratic. What is next? In the previous lesson, we have done something like this, and we know how to deal with it. We know how to shade the region. We will draw the parabola first, and then knowing how this is bigger than, I will use a dotted line instead, and then we will shade the region above the parabola. And then we've also seen how to do something like this. Like let's say this time, I have a vertex, I have a parabola in vertex form. I can come up with a parabola with a solid line. And this time, since it is less than, I will shade the region that is under the parabola at each point. So this is how we draw the inequality for a quadratic function. Now, what about solving the inequality if we only have one variable? One variable. So technically, it is more like back in the first week, we've done the parabola, we've seen how to draw a parabola, and then we solve a quadratic equation. There are multiple ways to solve a quadratic equation. We can solve it by graphing and find the x-intercept on your graph. We can solve it by factoring. We have a trinomial for the quadratic and we factor it. We've solved it by completing the square. We've solved it by using the quadratic formula. And now we are basically doing the same. We have a quadratic inequality. Instead of having a quadratic equation, we have a quadratic inequality. And if I want to solve it, I still need to figure out the x-intercept. We need more. When we are solving an inequality, we end up having a range of value for your solution. When you are solving inequality like this, we end up getting a range of value for your solution on your number line. If you want to graph your solution on the number line, you will end up having a range of value. In this case, everything bigger than 2 will be your solution. And now if we have a quadratic inequality, where do we get the range of value? And it turns out the x-intercept on your graph will help us to find the range of value. These two x-intercepts on your graph have now divided your solution into three pieces or three regions. This region, there are three regions for you to look at. You just don't know which one will be your solution yet. You are going to test it out using points like what we did in the previous lesson. We pick a point on one side of your graph and you plug it into your equation and you see whether the inequality will work. Same thing in this case. You pick a point on this number line. There are three pieces on this number line now. You pick one number from each piece, put it in, and for the piece that will give us the true statement. That will be your solution. Or, since we already have a graph, I can basically use the picture given to us. And for the parabola that is above 0, well, technically we used to have y in place of 0. But now, if we had to go in reverse, in which particular region do we have this parabola? The x-axis. Parabola is here. It is above the x-axis. It comes and then the x-axis. It is not what we want. We want our parabola 0 above the x-axis. The x-axis represents this is the equation for the x-axis. And now we want our solution to stay above the x-axis. On the right hand side. So in this case, if I have a graph for the parabola, right away. It could be anything bigger than 1, or it could be anything less than -2. This will be the solution to your quadratic inequality. By looking at the graph, you will be able to answer this question without testing your point. I'm going to show you how to test the point in case we don't have a graph at a later time. But for now, if we have a picture for the parabola, I can use the picture to answer the question. This time, if I want to figure out the places where my parabola is less than 0, or in another word, under the x-axis, less than 0 means under x-axis. This is the place where you see your parabola less than 0. It is under the x-axis. And it happens between -2 and +1. This is -2, this is +1. And in this case, if my solution is anything between -2 and +1, I will put my inequality this way. And since this is less than or equal, I want to use the same notation there. Compare the two solutions here. For the first one, we end up getting two pieces of inequality because your solution corresponds to different pieces. One on the left hand side and one on the right hand side. They are not continuous, and therefore you write your solution separately. But if your solution corresponds to only one piece, it is between two numbers, you would then be using one inequality to represent this one solution, this one region. So technically, when it comes to solving your quadratic, you will end up having a solution that is on the left side or in the middle. If your solution is in the middle, you will have an inequality written in this way. But if your solution happens as two pieces,